Here's our next example. I guess we'll call this example 3. It's the integral from 1 to infinity dx over x. That's the power p equals 1. And this turns out to be a borderline case. So it's worth carrying out carefully. Now again, I'm going to do it by the slower method rather than the shorthand method, but ultimately you can do it by the short method if you'd like. I break it up into an integral that goes up to some large number n. I see that it's the logarithm function is the antiderivative. And so what I get is log n minus log of 1, which is just 0. So this is just log n. In any case, it tends to infinity as n goes to infinity. So the conclusion is, since the limit is infinite, that this thing diverges. Now, I'm going to do this systematically now with all powers p to see what happens. I'll look at the integral, sorry, I'm going to have to start at 1 here, from 1 to infinity dx over x to the pth power, and see what happens with these. And you'll see that p equals 1 as a borderline when I do this calculation. This time I'm going to do the calculation the hard way, but now you're going to have to think and pay attention to see what it is that I'm doing. First of all, I'm going to take the antiderivative, and that's x. This is x to the minus p, so it's minus p plus 1 divided by minus p plus 1. That's the antiderivative of the function x to the 1 over x to the p, or x to the minus p. And then I have to evaluate that at 1 and infinity. So now I'll write this down, but I'm going to be particularly careful here. I'll write it down. It's infinity to the minus p plus 1 over minus p plus 1 minus, so I plug in 1 here, so I get 1 over minus p plus 1. All right, so this is what I'm getting. Again, what you should be thinking here is this is a very large number to this power. Now, there are two cases. There are two cases. And they exactly split at p equals 1. When p equals 1, this number is 0. This exponent is 0. And in fact, this expression doesn't make any sense because the denominator is also 0. But for all of the other values, the denominator makes sense. But what's going on is that this is infinite when this exponent is infinity to a positive power, and it's 0 when it's infinity to a negative power. All right? So I'm going to say it here, and you must check this at home, because this is exactly what I'm going to ask you about on the exam. All right? This is it. This type of thing, maybe with a specific value of p here. When p is less than 1, this thing is infinite. On the other hand, when p is greater than 1, this thing is 0. So when p is greater than 1, this thing is 0. It's just equal to 0. And so the answer is 1 over p minus 1, because that's this number, minus the quantity, 1 over minus p plus 1. All right? This is a finite number here. Notice that the answer would be weird if this thing went away in the p less than 1 case. Then it would be a negative number. It would be a very strange answer to this question. So, in fact, that's not what happens. What happens is that the answer doesn't make sense. It's infinite. So let me just write this down again under here. This is a test in a particular case. And here's the conclusion. No, I'm sorry. I think I was going to write it over on this board here. So the conclusion is that the integral from 1 to infinity dx over x to the p diverges if p is less than or equal to 1 and converges if p is greater than 1. And in fact, we can actually evaluate it. It's equal to 1 over p minus 1. It's got a nice, clean formula, even. All right, now let me remind you, so I didn't spell the word diverges right, did I? Oh, no, that's an R. I guess that's right. Okay. Diverges if p is less than or equal to 1. So really, I needed both of these arguments, which are sitting above it, in order to do it, because the second argument didn't work at all when p was equal to 1, because the formula for the antiderivative is wrong. The formula for the antiderivative is given by the log function when p is equal to 1, so I had to do this calculation too. This is the borderline case between p bigger than 1 and p less than 1. When p was bigger than 1, we got convergence, we could calculate the integral.